This is Mr. Ashton going through the Mathematics Intermediate Tier Non-Calculated paper from the summer of 2018. Okay, then, so the first question says, using only the number in the list, write down two prime numbers that have a sum of 32. So my top tip for this would be to go and look at literally just the prime numbers to begin with. So I'm going to highlight those in green. So we've got 11 as prime number because it only has two factors, one in itself. Any even number in this list we can discount straight away. 13 is, 15 isn't because 5 goes into it, 17 is, and 19 is. So now out of those four green numbers, we're looking to have two of them that add together to give 32. Now, 13 and 17, that's a number bond. That's actually going to be 30. So let's try 13 and 19. That would do it, okay? So 13 and 19 would do that. A number that is a multiple of both 4 and 6. So 4 and 6 go into this number. Okay, so in other words, this number has factors that are 4 and 6, which would be 12, because 4 times 3 is 12, and 6 times 2 is 12. So that answer there would be 12. And then this one's probably the meanest one, a number that has a number that is a factor of 51. So we're thinking of numbers that times together to make 51. So numbers that times together to make 51, you just need to go and test all of these ones. So if you start with 10, we know 10s always end in 10, so 10, 20, 30, 40, 50, 60, so no, that doesn't work. 11, no. 12, no, goes to 48, then 60. 13, and keep on going, and eventually you'll work out that it's 17, okay? 17 times 3 makes 51, so 17 is a factor of it. Okay, the next question, 2a, says, circle the correct answer for each of the following. 16 kilometres is approximately equal to. Now, be careful for this one. When I was looking through my model answers, I made a mistake here. Following conversion, okay? 5 miles is equal to 8 kilometres. Okay, so I didn't write this down, and because I didn't write this down, I ended up messing up the question. I'm then asked to work out what 16 kilometres is. So 16 kilometres would go there. What have I done to the 8 to get to 60? Doubled it. So I need to double the other side to get 10 miles. So my answer would be 10 miles. Okay, you can see then I nearly circled the 8 again just because of that definition. Another definition you should know off by heart is 1 kilogram is approximately equal to 2.2 pounds. Now in that case, I've actually solved it. It's that answer there. Okay, and then the hardest one again is say for C. 4 litres is approximately equal to. Now again, you need to know this definition. 1 litre is equal to 1.75 pints. Okay, now I've got to go and find out what 4 is, so I'm going to double it. Now, doubling 1.75 isn't as easy as it looks, so what I'm going to do is I'm going to split it into 1 and 0.75 and double those individually. So double of 1 is 2, double of 0.75 would be 1.5. Put them together and you get 3.5. So 2 litres would be the same as 3.5 pints. And then doubling that would give me 7. So 4 litres is equivalent to 7 pints. Okay? Over the page, and number 2, it says the table below shows some values of x from -4 to 6, and then complete the following table. Now, that's quite a nice formula because there's no coefficient to the x. It's literally just x minus 3. So in this case here, whatever your x's is, it's these numbers up above it. So the way that we got -7 here is that we did -4 in place of the x, take away 3 is -7. Here, x is -2. -2 take away 3 is -5. 0 take away 3 is -3. 2 take away 3, -1. And then 4 take away 3 is 1. And then 6 take away 3 is 3. The next thing I need to do is plot that onto the graph below. So -4 and -7 will go there. -2 and -5 go there. 0 and -3, 2 and -1, 4 and 1, and then 6 and 3. Now I'll soon find out if I'm right here because my ruler should go through all of those because there's no power with the x, so you'd expect to see that towards the end of the paper rather than at the start. Yeah, it does. Okay, and then it says on the other side of the paper, The straight line you have drawn from the graph of the values from -4 to 6, now that's in bold for a reason, okay? So from -4 to 6, so from -4 here to 6 here, is the diagonal of a square. Write down the coordinates of this square. So basically what they're telling me is that this is the diagonal of a square, so basically make a square. So if I draw lines that come down from here and across, from this, because it's the other corner of the diagonal, there. And let's make sure you can see what I'm doing here. Okay, the corners are here, here, which I've highlighted orange already, and here. Okay, so basically they want me to write those coordinates in these gaps here. So first of all, let's go with this one here, which is 6, 3. The next one, -4, 3. The next one, -4, -7. And then the final one, 6, -7. You can have those in any order. It doesn't matter if you've done it in the same order as me or not. You'd still get the marks for it, okay? Next question. It says, a bag contains a number of different coloured balls. A ball is selected at random. The probability of selecting the blue ball is 0.3. Explain the following statement. Why is the following statement incorrect? Explain your answer clearly. More than half the balls in the bag are blue. Well, we know that's not true. To be half full, it'd be 0.5, and that's less than 0.5. So I'm going to say, as 0.3 is less than 0.5, this is the probability of getting blue. There is less than half chance. It's less than half chance. Okay. Part B, it says, what is the probability of the ball being selected at random from the bag is not blue? Well, you need to know this following definition. We know that the probability of selecting the blue ball is 0.3, and they're saying what is the probability of it not being blue? So the formula that you need to know is that probability of not blue would equal 1 minus the probability of it being blue. So 1 minus 0.3 is equal to 0.7. Okay. Part C says there are 50 balls in the bag. How many of them are blue? So we're back to being blue now. Okay, this is a bit sneaky. We're going in between probabilities here. So we're back to 0.3. So it's always your probability times by the number of trials, so times by 50. Now, the problem is we don't have a calculator. I don't know how to do that without a calculator, obviously, but there's a really nice way to deal with it. I'm going to make this one 10 times bigger, so it's 3. But to counteract that, I can't go around making something 10 times bigger unless I make something else 10 times smaller. So 50 divided by 10 to make that 10 times smaller would be 50 divided by 10 is 5. And then doing 3 times by 5 would tell me the probability of getting the blues. I'd expect to get 15 out of 50. Okay, I wouldn't necessarily, but that's what I expect to get. Okay, over the page it says using the isometric representation of a Let's try that again. Draw an isometric representation of a cuboid measuring 6 centimeters by 4 centimeters by 3 centimeters. Use the grid below. Now, this grid is designed to help you draw these really, really easily. So if I go and measure, you want to measure your distance in between the dots is 1, so it's always off on this angle here. The same going off on this angle here. The same going up and down, okay? If you look in between 2 dots here, measure it. If it's not 1 centimeter, it's obviously not accurate to draw it that way. So going in between these 2 dots here isn't 1 centimeter, whereas going in between these 2, it is, okay? So I need to measure 6 by 4 by 3. So it really doesn't matter where you start, where you finish, but you might run out of room. That's why it's essential use a pencil. I'm going to start in a corner here, and it doesn't matter which way you go. I'm going to do, I can see I've got lots of space here to go back 6. So I'm just going to measure 6 and make sure it is perfectly 6. You can see that it is. To that dot there. So 6 dots, 6 centimetres. I am going to go across. Again, I've got plenty of space going across here. So 4. So again, I'm measuring 4 to make sure it's accurate. So that's the 4 centimetres dealt with. That's the 6 centimetres dealt with. Now just the 3. So I'm going to go up 3. Okay, now in essence, I've got my cuboid drawn. All I need to do now is the height of 3 from every vertex, and there. The next thing I'm going to do is make sure these measure 6 again. They do. Very important you check your drawings accurate. And then 4 again, yes. So I've nearly got my cuboid now. I just need to get the top bit done. So from this corner here, this vertex here, I need to go back 6. Again, measure it, make sure accurately it is 6. Yes. And then finally, join up the last 2 vertices. Should be 4. It is 4. Okay, there's a couple of other cuboids you could have drawn there. You could have drawn it on its side, or you could have the 6 going up in the air, or whatever. As long as you've got a cuboid 4x6, you will get the mark there. We're then asked for part B. It says calculate the volume of the cuboid. Give the units of your answer. Now we've got 6 centimeters times by 4 centimeters times by 3 centimeters. 6 times 4 is 24, and then 24 times by 3. Not the easiest calculation in the world, don't know off the top of my head. Let's try a different route. When you times it doesn't matter which order you go in, so let's try going the other way. 3 times by 4 is 12. 12 times by 6, I know that. That is 72. Centimeters times centimeters, so centimeters cubed. Okay, volume's always measured in cubic centimeters. Okay, the next question, number 6, gives a slightly different way of seeing this question that we're used to seeing. It tells us like terms, so it goes 2, then 5, then 8, then 11, then 14. And it says circle the correct equation that connects terms T6 and T7. Now, T1 just means term 1, term 2, term 3, term 4, term 5. So they want me to go and work out what is term 6 and what is term 7. But they want me to write it in an algebraic way. Okay, so basically, what am I doing to get from one term to the next? So how do I get from 2 to 5? I add 3, add 3, add 3, add 3. Okay, now there was another way to get from 2 from 5. I could double it to get 4 and add 1. You need to check that works every single time. Add 3 works every single time. So add 3, add 3, add 3, add 3. Here, if I double it and get 4 and add 1, yeah, that works there to get 5. Double it, 10, add 1 is 11, so it skips 8. Okay, so that's no good. So I'm adding 3 each time. I'm just going to write that on. Add 3, add 3, add 3, add 3. Okay, so I need to get from term 5 to get to term 6. It would be 17, but it would be term 5, add 3. I then want to get from term 6 to term 7, so that would be term 6, add 3. So I'm looking for that one there. Term 6 equals term 7 plus 3, that's not true. Term 7 equals term 6 plus 14, not true. Term 7 take away term 6 is 1, not true, so we're adding 3. Term 7 is equal to term 6 take away 3, not true, we're adding 3. Finally, it's the last one. Term 7 is equal to term 6, add 3. Now, the next one is probably harder in some respects, but it's going to be easier because you're more used to seeing these type of things. It says the nth term of another sequence is 2n take away 11. Write down the value of the 10th term. Now, n is just representing any number in the sequence. I want to find the 10th term, so what I do is I substitute 10 in. Now, if it's touching it, I always change it to open brackets, which means it's timesing it. And then take away 11. 2 times 10 is 20. 20 take away 11 is 9. Okay, the third term, 2 brackets 3 minus 11. 2 times 3 is 6. 6 take away 11 is minus 5. Okay, next question. Question number 7. Take a moment to read it. Going to have a good think through this one now because it's not easy, this one. It says, find the whole number that satisfies all of the following conditions. It is a whole number between 1 and 100 inclusive. Now, that means it includes 1 and 100 as well as all the numbers in between it, okay? 10% of the number is greater than 2, but less than 8, okay? So it's greater than 2, but less than 8. Now, what I'm going to do is start trying to write that out. So 10% is equal to 3. So 100%, the whole number would be 10 times as much. So it could be 30. 10% could equal 4. So 100% would equal 40. 10% could equal 5. So 100% would equal 50. 10% could equal 6. So 100% would equal 60. 10% would equal 7. So 100% would equal 70. Now, I can stop there because we know that 10% of the number is greater than 2. So 3 is greater than 2. Less than 8. 7 is less than 8. There's no other numbers now that fit that. We're then told that half of the number is a square number. So we now need to go and find half of 30. Half of 30 is equal to 15. That is not a square number. Half of 40 is equal to 20. That's not a square number. And no number times by itself is 20. Half of 50 is 25. Now that is a square number. Half of 60 is 30. It's not a square number. And then half of 70 is equal to 35. And that's not a square number either. We're then told underneath, it says the number is not a multiple of 4, but we've already solved what it is, and that just sort of reaffirms it. The number is not a multiple of 4. 50 is not a multiple of 4. That's the only one that's half it is a square anyway, so the number there is 50. Okay, question number 8. Now, you will see this bit here, which is really important. It says, in this question, you will be assessed on the quality of your organisation, your communication, and accuracy in your writing. In the diagram below, ABCE is a square whose perimeter is 28. Now, what I'm going to do is I'm going to draw that out here straight away. Now, the perimeter, so what did they say it was? It was ABCE, so it's this guy here. We know that a distance around that, if I ran around it, would equal 28. Okay, so I'm going to say perimeter is equal to 28. So that's all the sides added together would give me 28. Now, because this is a square, all the sides are the same. So I'm going to do 28 divided by 4 tells me that each side is 7 centimetres. So I'm going to say one side of square equals 7 centimetres. Now, notice that I'm writing centimetres throughout and I'm showing any calculations I did. I might put an arrow here and just explain why I divided by 4. So I'm going to say divide by 4 because all sides are the same. You can see I'm just running out of room slightly there. I shouldn't really write it down in the exam, but it'll do for now, okay? Divide by 4 because all the sides are the same. It's a square. That's the definition of a square. So I've dealt with the first statement already, and now I know that's 4 centimetres. That's 4 centimetres. It's not 4, I'm lying. They're all 7. That's 7 centimetres. That's 7 centimetres. That's 7 centimetres. And this is 7 centimetres. Okay, so the next thing that I'm told is CDE is a right angle triangle whose area is 35 centimetres squared. So again, I'm going to draw that out below. Now, I've just gone and worked out what this side is. That's 7 centimetres. I don't know what the height is. Okay, so I'm going to call that H. I put in my right angle because they've told me it's a right angle triangle. And I know the formula for a triangle is area is equal to base times height divided by 2. Okay, and I'm just going to explain what that is. That is the formula to find area of a triangle. Okay, Now, I know what the area is. They told me in the question. They told me it's 35 centimetres squared. So I'm going to just put this in as 35. I'm not going to put in the centimetres squared because I want to work with the numbers here. This is my final answer that I want to put the units in, okay? So 35 is equal to 35 is equal to the base, which is 7, times by the height, which I don't know, and then I divide that answer by 2. Now, I don't want to know what 7 times the height divided by 2 is 35. I want to just know what the height is. So what I'm going to do is times both sides by 2. 35 times 2 is 70, is equal to 7 times by the height. And then, to work out the height, I'm going to divide both sides by 7 to find out that the height is equal to 10 centimetres. Okay? And that is DE. So I'm going to say DE equals 10 centimetres also. Okay? Okay, the next question asked me to reflect the shape S in the line y equals 1. So what I need to do is draw that line y equals 1, which is drawn wrong incredibly regularly. It tells you what to do. Y equals 1. Find y, find where it's 1. Okay, there. You draw a line that goes through there. 1. Label it y equals 1. Now, let me just explain. Anywhere on this line, the value of y is always equal to 1. If you come off and read it, the value of y is always equal to 1. The value of x changes. Look, x is 1, y is 1. X is 2, y is 1. X is 3, y is 1. Every time y is equal to 1, even in the negative. So that's why it's y equals 1. The y-axis goes up and the x goes across, but the line y equals 1 goes through the y-axis at the value stated. Okay? Now, the way that I do this is I count from the line. I say this vertice, this corner, is 2 away from the line. So it needs to be 2 away in the reflection. Then this corner here is also 2 away. So 1, 2, there. This corner here is 1, 2, 3 away. So it needs to be 1, 2, 3 away here. This corner is 1, 2, 3, 4 away here. So it needs to be 1, 2, 3, 4 away here. This one is also 4 away. And then this one is 1, 2, 3 away. So 2, 3 away there. And I should have an L shape mapped out by its vertices. And then do all the straight lines pointing down just to save me having to go around with the ruler the whole time. There. There. And there. Okay. Now what it should look like is that if I folded those two onto each other, is that they would meet up on each other. Okay. So hopefully you can see that it would start to do that. Okay. That's what a line of reflection does. Okay, the next question will require some tracing paper. And it wants you to describe the single transformation, that word is important, that maps S to T. So here to here. Now, in terms of transformations, there are 4. There is a translation. Now, a translation just means it has been moved from one place to the other. There is a reflection like we just did. Okay, so it looks like it's been flipped in a mirror. There is a rotation, so it looks like it's been spun around. And then there is an enlargement. So let's go through and work out which one of those it is. Is S to T exactly the same shape? If I picked it up and moved it somewhere else, no, it looks different. It doesn't look exactly the same. It is not a translation then. Does S look like it's looking at itself in the mirror? No, it doesn't, so it's not reflection. I'm going to skip 3, or actually we can have a look at it. Does it look like it's been spun round? Yeah, it does, so it could be that. Enlargement, does it look like it's got any bigger? No. Well, there we go then. We know which one it is. Okay, now there's 3 marks available here. We will get 1 if we state rotation. I have to state what direction, how much it's been spun by, and where from. Okay, so let me show you how to do that bit there. You get your tracing paper. It wants us to go from S to T. So what we do, you don't have to do it absolutely miraculously. You can use a ruler if you like, but I'll do mine freehand. Okay, now, a good place to have a guess every single time is the origin. I'd be surprised if it's not there in some respects. So what I'm going to do there is colour where the origin is, and I'm going to go from S, this was triangle S, to shape T. I'm going to move it the same way that the hands move around a clock, so we call that clockwise, and see if it fits on it. Look, it does, okay? If it hadn't, all I would have done was try a different set of coordinates, say, for instance, 1, 1. So I would have tried doing a spin there and go, oh, look, it doesn't fit. It doesn't fit at all, okay? However, it did fit from here, okay? Now, that was a quarter of a turn. This would be half a turn, down here, 3/4 of a turn, and a full 360 back to itself, okay? Now, in terms of that, it was quarter of 360. So it was 90 degrees, and I moved it clockwise. And then I've got to say where it is from. So from the origin. But instead of saying origin, I could have said 0, 0. That's the same thing, okay? So the marks they'll give you, one there, one from saying 90 degrees clockwise, and then one from saying at the origin, okay? Now, what we could have actually said was that it was, if I put it back here, if I went the opposite way around so the hands move around the clock, so 1/4 turn, half a turn, 3/4 of a turn, but I went the opposite direction. I could have said it's 270 degrees anti-clockwise. That would have also given me the mark, okay? Okay, question 10. Question 10 says, circle the best approximate value for the calculation. Now, to do this, you want to round everything to one significant figure, okay? Now, to do that, you put a line down after the first non-zero number. We'll round it to each of those. So this, in this case, the nearest 100, the nearest 10, the nearest 10. 596 would round to 600. 38.2 would round to 40, not 38. And 11.5 would round to a bit too hard if you do it any other way. 600 is 600 divided by 40 plus 10. What I need to do now is actually do 40 plus 10, which is 50. Divide top and bottom by 10, effectively cancelling a 0. 60 divided by 5 is 12. There. Okay. Next question says, a number is increased by 4% of its value. This is done 7 times. This is done 7 times, each time increasing the previous value by 4%. Circle the multiplier that you would use to find the value after the 7 increases. Now, they are expecting you to know that a multiplier is used by finding the original amount. Because it is an increase, I am adding not 4%, sorry, I am adding 4%, not 7%, to get 104%. Now, 104% means 104 out of 100, and 104 divided by 100 would be 1.04. So it's got to have 1.04 in it. Any ones that I can cancel out straight away? That one, not that one, that one. There's 3 of them gone straight away. Now, in the first year, I would times it by 1.04. Let me see. I'm just going to come work down here. In the first year, we have, let's say, £1,000, and we're going to increase it by 4%, so we times by 1.04. That's the first year. Second year, I times by 1.04 again. Third year, times by 1.04 until we get to the 7th year. How many of those are going to be there? That was year 1, year 2, year 3, year 7. We're going to have £1,000 times by 1.04 to the power of 7 because there are time signs in between it. So that's the one I'm looking for there. Okay. The next one says calculate the answer to 4/5 divided by a quarter. They are expecting you to realise that dividing by a fraction is very hard. So what you do is you change the sign to a time sign and you flip the other fraction, the second fraction, and then that's much easier to solve. So 4 times 4 would give me 16, and then 5 times 1 would be 5. So I'm looking for 16 over 5. Now it's not there, okay? Now the one thing I can say is that that means 16 divided by 5. I know it's certainly not 5, and I know it's certainly not 1 over 5, and I know it's not 5 over 16. It's none of those. So it's either this one here or this one here. if I'm counting how many 5s go in 16, I count 5, 10, 15, 16 is a little bit more. So that went in at least 3 times, and there's 1 left over. So not 1 3/5, but 3 1/5. Okay, next question. Okay, the next question is about Venn diagrams. Have a quick read of it. I always find Venn diagrams tricky ones, very easy to go wrong on, so just be careful. Have a quick read. Okay, it says 30 rugby supporters travel to Cardiff on a coach. They decide to investigate how many of them can sing one or both of the songs, Hen Rather Than Had I and Bread of Heaven. 12 say they can sing both songs. Now, in a Venn diagram, the overlap represents they can do both. So this is singing Hen Rather Than Had I, and this is Bread of Heaven. So 12 will go there. 18 say they can sing Bread of Heaven. So all of this circle has got to add up to 18. So if I've got 12 now already, that must be 6 that's left over. Finally, 5 say they cannot sing either of the songs. So this is a song, this is a song. Everything outside in this rectangle represents nothing. So this bit would be 5. Okay? Now, I know there were 30 rugby supporters. So far, I've accounted for 12 and 6, that's 18. That's these 18 here. And another 5, so that makes 23. So that leaves 7 that must go there. Okay? Part B then says, one of these supporters is chosen at random. What is the probability that this person can sing Hen Rather Than Had I? So basically, how many people are in this circle here? So 7 and 12 make a total of 19. And because it is a probability, that would have been out of the total number of people there, okay? So out of 30 in both cases. Number 12. Expand the following expression and simplify. So the letter or number on the outside has to multiply both of these things inside the bracket. So x times by 5x would be 5x squared. X times by minus 2 would be minus 2x. This is the one to watch out for. First of all, it's got 3 things to multiply. That's not usual. We get asked that in an exam. Here that does the damage. That belongs to the 3. So I need to do minus 3 times by x squared. Well, that's easy. Minus 3x squared. This is where you need to watch out. Minus 3 times by minus 2x. That is going to be plus 6x. Not minus because it is a minus times by a minus. Then I've got minus 3 times by plus 7. So again, this is where people are going to lose the mark. That's going to be negative 21 because a negative times by a positive is a negative. Okay? Next thing I'm doing is I'm looking for anything with an x squared. We've got 5x squared, we've got a 3x squared, but I've just made a cardinal sin. That minus also belongs to the 3x squared, okay? So that's telling us the first thing we need to solve, which is 5x squared minus 3x squared, which would be 2x squared. The next thing I'm going to do is find anything with an x in it, including the sign in front. So minus 2x and a plus. So minus 2 add 6 is a bit of a weird way to think about it, but if you switch it the other way around, 6x take away 2x will give me plus 4x. And then finally, I've only got one number term, so no need to do highlighters here. I could do just to show that it's different. There. So that minus 21 would just get plonked on the end because it's got no x or x squareds in. Okay, part B says solve the following. 22 minus f all over 3 equals 6. The first thing I'm going to do is put an arrow down and put a new equals there and line up the equals. I'm going to get rid of anything that's not physically attached to the f. And what was the last thing that was done? Well, the last thing that was done was all of it was divided by 3. So I need to times that by 3. But whatever I do to one side, I need to do to the other. So 6 times 3 gives me 18 here. The divided by 3 and the times by 3 cancels to leave me with 22 minus f there. Okay? Now, I don't like having my f negative. So what I'm going to do is add f to each side. So I'm going to get 22, they cancel there, is equal to 18 plus f. And now what I'm going to do is get rid of anything that hasn't got f in it. So I'm going to take away 18 from this side and from the other side to get 4 is equal to f. Okay? Now that just means f equals 4 as well. Either of those ways round is absolutely fine. Finally, on this page, number 13a, it says a fair-sided dice is thrown twice. What is the probability that 3 is shown on both occasions? Now, people get this question wrong all the time. Let me just show you very quickly. I'm not going to do it all of this way. I'm going to show you a much quicker way by doing a two-way table. If I roll the dice, these are all the numbers I could get on throw number 1. On throw number 2, these are the numbers I could get. Agreed. Okay, so that's throw number 2. Now, the rolls I could have got was a 1 and a 1. I could have got a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. I could have got a 2 and a 1, a 2 and a 2, a 2 and a 3, and so on. Here is the only place that happens where I get 3 on both occasions, where I get a 3 and a 3. I need to work out how many rows there are in total there. There's going to be 6 rows, and on each row, there's always 6 different answers I could get. So I've got 6 lots of 6. Only once is it 3 and 3. So the answer is 1 out of 36. But a much quicker way to do it is say the probability of getting a 3 on the first occasion and the probability of getting 3 on the second occasion would remain the same. They'd both be 1/6. And you multiply those two probabilities. 1 times 1 is 1. 6 times 6 is 36. Have a quick read of the question then I'll start to complete. Okay, it says, a company has offices in Llanelli, Carnarvon, Newtown and Ebbw Vale. Its company committee, or its national committee, is made up of workers from these 4 offices. The pie chart shows the fraction of the committee members that come from each office. Now, they've already told me that Llanelli is half of that chart, and I can see quite clearly that it's cut in half. Now, if that's cut in half, that's 180 there. That means that's 90 there because of the square. So that must be a quarter for Carnarvon. In terms of what a quarter cut in half, so a half of a quarter would be an eighth. There and there. Okay, so that's what those missing fractions are there. It then says, what is the probability that the member of a chosen as a chairperson works at either Llanelli or Ebbw Vale? So Llanelli is a half, Ebbw Vale is an eighth. So what I need to do is get those two fractions, and because I'm looking at the chances of it happening in either one of those, I add them together. Okay, a half and an eighth I can't work out without a calculator at the moment because these denominators are different. So what you need to do is change the smaller one into that one ideally if we can. If they can't, we'll have to find a number they both go into, but it might be a bit premature to do that because I know that 2 does go into 8. What do I times 2 by to make 8? 4. So a half is the same as 4/8, and again I can show you up by here. 1, 2, 3, 4 for Llanelli, and then 1 for Ebbw Vale, which will give me a total of 5/8. Okay, question 14. Quite a hard question on a non-calculated paper. Now, this one is tricky, so if you find this question hard, good. You should do it. It's challenging, this one. It says, calculate the value of 2 times 10 to the minus 4 times by 7.8 times 10 to the 9. Now, the first thing you're going to do is do what it says with the numbers. Okay, 2 times by 7.8 is 15.6. It will be times 10 to some power. That power is going to be... The rules of indices state that I add these two indices. So it would be times 10 to the power of minus 4 add 9, which would be to the power of 5. Now, the problem is this answer is not in standard form. To be in standard form, this must be a number between 1 and 10. It cannot be bigger than 10. Okay, it can't actually be 10 either. It's got to be... Now, to make that number smaller, what I'm going to do is divide that by 10. But I've done this earlier in the video. If I divide something by 10, that's going to get 10 times smaller. I now need to do the opposite to that to make it still the same size as it was originally. So I'm going to make this 10 times bigger. Now, if I have 10 to the power of 5, this would effectively be 10 to the power of 1 And as we just did, you add those indices together, so we get 10 to the power of 6. Okay? Now this one here, you need to write the denominator into standard form to complete this. You can't complete it as it currently stands because you can't use the rules. Now 3000 would be 3 times 10 to the power of 1, 2, 3. To the power of 3. Now you are going to work out what is 3.9 divided by 3. That would be 1.3 times 10 to the power of 5. Okay, and that one's actually fine. That was already in the right form. And then the one underneath says factorize. So we're looking for a number or a letter or both that goes into the expression at the bottom. So I can see 3 goes into both. I can see x is in both. So I take 3x out as a common factor. Always the lowest power of x. We've got an x squared and an x. And then what times 3 makes 12? 4. And then x times what makes x squared? 4x. And then similarly here, plus, because it's a plus sign, 3x times what makes 3xy? That would be y. Okay? Question 16. I snuck this in. They've not really told you it's coming up. It's quite a sneaky one. It says calculate the value or calculate the size of angle. What they are looking for is that you are recognizing that this is a circle there, and within it you have got what is called a cyclic quadrilateral. The nice thing about this is they haven't actually asked you to explain, but what you should know as a B grade topic, a top B grade topic at that, is you should be able to work out what that angle is purely because you know what this angle is. Now, the theorem that we're using here is called cyclic or opposite angles in a cyclic quadrilateral add to 180. So if I do 180, take away 71, I will find out what that angle is. So borrowing 1 from there, 10 take away 1 is 9, 0, 1. So this angle here is 109 degrees. Now I've got a triangle, so if I do 109 degrees, add the 26 in this corner here, that gives me 15, 3, 1. That tells you that these two angles make 135. So I need to do 180 take away 135 to get 5, 4, 0 to find out that x is 45 degrees. Okay, so the way I did that was I used circle theorem, opposite angles in a cyclic quadrilateral add to 180 degrees. Now, they haven't asked me to write that down. I'm just telling you that, okay? So no need to write that down, but they usually do ask for the reason. Okay, then, question 17. Now, this is quite a tricky one. There's a lot of conditions going on here. So I'm going to have a go at doing it now. I have got my compass. So it says the line AB is drawn below. The point P is above the line AB. So we know this line AB, the point is above. So it won't be anything down here. It won't be below this line. It says the region in which P is located is such that P is nearer to point A than point B. Now what that's asking me to do is to bisect AB. To bisect AB, it means cut into 2 equal pieces. Just move the visualizer so we've got you nice and clear. Now the way that you bisect a line is that you open your compass to obviously more than half of the line. Okay, to obviously more. Now I think that is now obviously more. You put the point on one of the letters and you draw a semicircle there. You now move the point over to the other side of the line and you draw another semicircle without altering the width of your compass. Okay, so far, that's all we need to have done. To bisect that, you line your ruler up with the 2 intersections and we draw a nice firm line that goes right up to the question. Now, in some respects, I'm not interested in this part of the line at all because I know the point is above this line, okay? But I'm going to draw it all in to show you exactly what I'm doing. It then says BAP, so going from B to A to P, is less than 60 degrees. Okay, now to make 60 degrees, you need to know how to create that angle. That is done by creating an equilateral triangle. Now, the way that I'm going to do that, I'm going to open my compass to exactly where we met there. Okay, I'm going to draw an arc from that line to there. Oh, now my compass has just budged, so what I'm going to do is just reset it and make sure it's done properly. There. So that first line up here, I just want to ignore. I'm now going to move my compass to where it hits the line. And there to here would create an equilateral triangle. Now, I know it's angle A because that's the one with the hat on. So I'm going to draw A up right until the question. Now that angle is exactly 60 degrees. If I went and measured it with an angle measurer, you can see there that it's exactly 60 degrees. Okay, you don't need to go and join this one up to there if you did it at angle A. Okay, so angle A has now got 60 degrees. Now we know that it's less than or equal to 60, so it's got to be below this line, above this line, and it is nearer to point A, so it's somewhere in this triangle here so far. Okay, and then it says AP is greater than 6 centimeters. AP is greater than or equal to 6 centimeters. So what I need to do now is not rub out any of these lines. They're called construction lines. I open my compass to exactly 6 centimeters, which I've done there. Now AP. So AP would be around A. Now it's really confusing because it's really close to what my first arc was here. So it's the outer one of that. Now, because this is greater than or equal to 6, it is everything on that line and higher within the triangle, okay? So the area that I want is this bit here that I'm starting to shade in, okay? Now, you can see I'm being really, really, really fussy the first time I do it. Let's start doing some bigger pencil strokes now. That was the area I wanted. That's quite a tricky one for loci and sort of identifying the area. It's not usually as tricky as that. Okay, then on to the last question now. Have a quick read. Okay, then. Now, the key bit in this question is this bit here. That is the most important bit in the question. This is where you will fall down if you don't tell them absolutely everything you're doing. Okay? We're told in triangle ABC, shown below, B to A to C, so B to A to C is 40 degrees. And A to C to B is 80 degrees. X is a point on the side AC, so that's what X is, such that BX, this line here, is equal to this line here. So we know these two lines are equal. Okay, so what we normally do when we have two equal sides mathematically is we put a dash on them like that. Okay, now what that should tell you now is that this angle is 80 degrees. Okay, now what we need to do is explain that that angle is 80 degrees. So how do I get to this angle? I go from C to X to B, or the other way around, B to X to C. So I'm going to say C to X to B, and put the little hat on the angle, is equal to 80 degrees. And the reason why that is I'm going to say because XCB, any order of those letters will be fine, is isosceles. Okay? The next thing I can work out, because it's an isosceles triangle, is I can go and work out what this angle here is if I wanted to. I don't know if it's a huge amount of use, but what I could go and work out here is 80 add 80 is 160, so this must be 20 degrees, okay? So 20 degrees, I'll just point to that and say missing angle in triangle. So there's no reason why you can't go and draw on the diagram and give reasons there as well. And I'll let me say what angle that is. That's C to B to X, C to B to X, C to B to X, missing angle in triangle, okay? The next one I'm going to work out is this angle here. How can I do that? That's a straight, oh, you can't see what I've done. That is a straight line, okay? So because that is a straight line, we can say angle A to X to B, A to X to B is equal to 100 degrees because angles on a straight line add to 180 degrees. Okay, so that's got to be 100 degrees. Well, now I can go and do exactly the same sort of idea and work out what this angle is here. 100 add 40, and what makes 180? So let's add those together. So 100 degrees add 40 degrees is 140 degrees. 180 take away 140 is equal to 40 degrees. So X to B to A, X to B to A, it should be the middle letter that has the hat on, is equal to 40 degrees, meaning XAB triangle is isosceles as two angles are the same. So where are they the same? Well, that's 40 degrees. That means that this line here and this line here must be the same, okay, because those angles come in underneath. Oh, sorry, this line here must be the same because those angles come underneath. So this was the line X to A, this was X to B, and that's what they wanted me to go and prove, okay? So AX is equal to B. If that paper's been useful, please subscribe to the channel and you'll get updates to any more papers when they get released. Thank you.